Well, ladies and gentlemen, can I just say again what a great privilege it is to be here in Sydney, and as was already mentioned, a special welcome to those who are coming to these lectures for the first time. I was particularly interested just looking at the list of previous New College lecturers up there, which was going around in front of us before the lecture, and noticing the name there of Professor Malcolm Jeeves, 1987 I think it was, when he came here from St Andrews University to give those lectures that year. I saw him a couple of weeks ago, and he's still doing well. He had his 90th birthday celebration with a number of his academic colleagues and people that he's trained over the years. He's a wonderful neuroscientist, and I know that that 90th birthday was already some time away, and he's still publishing. And every year, you know, books and articles come out by Professor Malcolm Jeeves. So an example to us all, I would say, and a fantastic colleague to know. Let me start this evening by providing just a brief resume as to where we've got so far in this lecture series. I realize that, as I said, some might be coming for the first time, and even for those who've been coming faithfully every evening, thank you. I think sometimes a little resume can be quite useful. So in the first lecture, we laid out the big picture. We examined some of the techno-scientific challenges that we all face at present and will face even more in the future, in particular those arising from artificial intelligence and robotics, from genetic engineering, and also from brain manipulation. And we then laid out three of the big rival metaphysical systems of thought that shape the ways in which we think about these challenges, particularly when it comes to our values and our ethical decision-making. And the three areas of thought we introduced were transhumanism, quote, a liberation movement advocating nothing less than a total emancipation from biology itself. Secondly, middle-of-the-road Western secular humanism, or what I've chosen to call MOR-WSH, as a simple sort of acronym to remember, which has a much more pragmatic, utilitarian approach to ethical questions. And then also we talked about Christian theism with its God-given basis for the value of all human beings. And all these worldviews raise questions concerning human responsibility. For example, implicit in the Judeo-Christian concept of humankind made in the image of God is the assumption of human moral responsibility. And that then led us onwards to the lecture last night, lecture number 2, when we addressed the question as to whether we really do have free will with its entailment of moral responsibility. And the question, is genetic determinism a threat to free will? And we came, or perhaps more truthfully, I came to the conclusion that it's precisely because we do have our particular human genome with our particular developmental biology, which results in beings with nervous systems of a particular kind of complexity, that genuine moral responsibility is what emerges. We also concluded that the genetic variation that we find in human populations may make differences to our choices in a probabilistic kind of way, but only in cases of severe genetic pathology is our free will truly subverted. So, where are we going this evening? Here's a roadmap for this evening. So we talked quite a bit about machines in lecture 1, but tonight I want to start by explaining a bit about what genetic engineering involves, and then the current state of play with human genetic engineering and what that could involve in the future. Second, I'd like to summarize the ethical toolkit, I'm going to call it, that is currently in use by all people addressing the moral dilemmas involved in human genetic engineering, with a particular focus on the ways in which the big rival metaphysical worldviews that I just mentioned modify and influence this toolkit. We'll see more of that as we go along. And then third, we'll see how those worldviews impact on the discussion about the distinction, if there is one, between healing and enhancement. And then lastly, we're going to apply our ethical toolkit to some real-life examples. So if you felt the first 2 lectures, those who've been coming faithfully every evening, if you felt them, they were a little bit too theoretical, hopefully tonight you'll feel it's more like a practical workshop. We're going to get down to business and look at some specific examples. So what is genetic engineering? Apologies to biologists here and people whose field this is, but this is obviously a very multidisciplinary group, and so I think it might be good if we just spend a few minutes thinking about that. In some ways, I think the term genetic engineering is an unfortunate one, as it conjures up methods dependent on artificial materials, kind of engineering techniques that we're familiar with in building cars and aeroplanes and so forth. The wicked scientists who create monsters in horror movies generally seem to be surrounded by lots of wonderful machines, giving the impression that genetic engineering is a very sort of high-tech kind of enterprise. In reality, the opposite is the case. So the traditional techniques and materials used by molecular biologists to manipulate DNA are mostly taken directly from the natural world, where they have precisely the same functions, albeit used in different contexts. And humankind has been involved in genetic modification for thousands of years. For example, in pollinating date palms in ancient Babylon 3,000 years ago, even though, of course, the mechanisms involved in that were not understood at the time. The breeding of domestic dogs, maybe that's a little bit close to home, provides a further good example. All of the same species, but in shape, size, and personality highly distinct. The sequencing of the dog genome, that's all the DNA in the sequence DNA you find in a dog, and detailed comparative analysis have revealed that only a small number of genetic variants generates this impressive diversity. Dog breeders have been altering dog DNA now for centuries, albeit not by very much as it turns out. So that sort of genetic manipulation is nothing new, and genetic engineering should be seen as, I suggest, a set of techniques that dramatically speeds up to what is in any case going on in the natural world around us and what humanity have been doing in the biological world, albeit on a much slower timescale. And because molecular biology is basically a simple process of cutting and pasting bits of DNA, hundreds of so-called garage labs have sprung up around the world in which DIY hackers play around with DNA using the basic tools of molecular biology as a hobby. And indeed, that might terrify you when you think of the implications of that. Until 2012, the problem for modifying the DNA of a cell was that when you inserted a foreign bit of DNA into the cell, there was really no way of knowing where that piece of DNA would end up in the cell's own DNA, in other words, where it would integrate. As mentioned in Lecture 1, that situation changed dramatically with the discovery of what we call CRISPR-Cas, which is an acronym, and it doesn't really matter what it stands for our purposes this evening. CRISPR-Cas is a molecular complex which has the ability to change the DNA of any organism, including humans, with a very high degree of specificity at any particular position in the DNA in such a way as to potentially alter the properties of that organism. When we talk about Cas, the Cas bit of the system is in fact an enzyme. It's a nuclease that cuts the DNA at very precise places. So if you like, it's like guiding a pair of scissors to precisely the right spot in the DNA. The same system can also be used to repair mutations in a given gene that may be causing disease. Mutation refers to a change in the normal sequence of genetic letters in the DNA. So we now have in our hands a very powerful tool that can change the DNA sequence very precisely of any organism in the world, including us. And so the genie is really out of the bottle. And so far this year, and I just checked a couple of weeks ago, there have been around 1,200 scientific papers published in the world with the acronym CRISPR in the title. We're talking about a huge explosion here of the application of this powerful technology. Now, in terms of healing, the genetic engineering of humans currently has three main types of application. In the first type, human cells are genetically modified to make them work more efficiently. At present, there is huge interest in harnessing the immune system, my own field of molecular immunology, for more effective cancer therapy. And on the screen before you, you've got some of my favorite cells I worked on for 20 years, T cells. It's now possible to take a cancer patient's own T cells and genetically engineer them using CRISPR-Cas so that their recognition mechanism, or the mechanism that recognizes foreign antigens, in this case known as chimeric antigen receptors, specifically recognize the tumor in that patient. And then those T cells are multiplied up in the lab and then fused back into the patient to kill the tumor. And such approaches, still very much in the experimental phase, have led to some dramatic successes in patients with various cancers. The second type of human genetic engineering for healing is aimed at those 10,000 or more genetic diseases, some of them very rare, caused by a defect in a single gene. And success in this area has just started coming over the past few years, and there are now hundreds of clinical trials going on in the world using this type of approach. This particular picture shows a child called Daniel, healed from a rare genetic disease known as Wiskott Aldrich Syndrome. Daniel was diagnosed with a condition age 2 and had needed frequent medical care to manage his symptoms, which included severe asthma and inability to fight infections. In fact, his older brother had died from complications linked to this disease. So in this case, the technique involves taking the bone marrow from the patient, transferring into the cells the gene which is defective in the patient, and then putting the genetically engineered cells back into the patient. And Daniel is now aged about 18, and he's doing fine. He has been healed to all the follow-up tests done so far. Now, like any medical therapy, there can be complications, there are often setbacks and disappointments, but gradually new genetic therapies are making a difference to the lives of those with cancer and with genetic diseases. But, of course, the therapy only applies to that individual patient. There is no transmission of modified genetic information to the next generation. So I think there are no particular ethical challenges in such novel therapies, except, of course, for the need to be concerned regarding safety issues. But that's true with any novel medical therapy, and, of course, no new treatment is ever totally risk-free. But now what about the third approach? A new development in which CRISPR-Cas is being used to heal human embryos in the laboratory. If the healed embryos were implanted in a mother with a successful birth, a procedure at present illegal in most countries of the world, including here in Australia, then all subsequent generations would be healed of that particular disease. First paper to report such a procedure was from a research group in China just a few years ago in 2015, using embryos carrying the mutation that causes the blood disease thalassemia. And in that work, in that very early work, early being only 3 years ago, only 4 out of the 86 embryos injected with CRISPR-Cas, that is 5% of the embryos, was the mutation corrected. But since then, already in the period of 3 years, the technology has been much improved. For example, last year, a human embryo editing paper was published by a group based in Oregon in the USA. There's a gene called MYBPC3, which causes thickening of the heart muscle, a leading cause of sudden death in young athletes. This group fertilized 58 human embryos with sperm from a person with mutation in their MYBPC3 gene, and then used CRISPR to correct the mutation successfully in 42 of those embryos. And then there have been around a dozen reports, I guess, of such embryo editing experiments, not yet all published, and the techniques are gradually becoming more successful. And clearly the aim here is eventually to obtain ethical permission to implant the healed embryos in the mother to generate a genetically corrected baby. But the main practical objection raised is this: why bother when pre-implantation genetic diagnosis, PGD, is available? Here, as I'm sure you'll know, embryos are screened in IVF clinics for a known mutation that causes disease in the family's history, and only the healthy embryos are implanted in the mother. And in the vast majority of genetic disease cases, such embryos will be available. So, is it really worth developing such a complex, expensive, and potentially risky technology as genetic engineering for the benefit of such a tiny number of cases where, in fact, pre-implantation diagnosis should be feasible? It's also worth pointing out that disease-causing mutations can occur during development of the sex cells. So in these cases, there is no family history, and therefore no warning that a deleterious gene might be present in the newborn. For example, about 1/3 of all cases of Duchenne muscular dystrophy are due to new mutations that occur in the sex cells of one of the parents who themselves are disease-free. And if such embryo editing did eventually become both safe and routine, as seems quite likely, then will there be increasing pressure to use the same approach for human enhancement? Is this a slippery slope? After all, why not use embryo editing to enhance the human genome, to make people more intelligent, to generate better athletes, stronger soldiers for your army, something like that? And for years, books and papers have been coming out promoting human enhancement by technical means. Here's a paper from the journal Bioethics, 2004, and the title says it all, doesn't it? The Inevitability of Genetic Enhancement Technologies. That was already 14 years ago. And the authors comment, and I quote, that we contend that the inevitability of the technologies results from a particular guiding worldview of humans as masters of the human evolutionary future. Close quote. Very interesting quote there. It's also probable that in the not-too-distant future, CRISPR editing of the cells that develop into sperm and eggs will also be possible. So, for example, if there is an X-linked disease carried by the mother, such as muscular dystrophy, for example, then eggs could be produced that are genetically engineered to remove the mutation right there at the beginning. The disease-free child will then be produced by IVF, so avoiding the need to genetically modify the embryo. And there has been already some success in modifying mouse and non-human primate sex cells in this way. The same approach could by the same token greatly increase the discussion about human enhancement. Now, it is true that the borderline between healing and enhancement is not always completely clear. For example, I think everyone here in this room, without doubt, have been vaccinated, and therefore we all have, to some degree, enhanced immune systems. Some of us here, I'm not one of them, but some here take daily statins to reduce their blood cholesterol, or some of us, like myself in this case, take a low-dose aspirin every day to prevent heart disease and strokes, so we're medically enhanced. The use of human growth hormone to help small children grow bigger has well illustrated, I think, the fuzzy boundary between healing and enhancement rather well. There's a huge variation in height, isn't there, in people around the world. Should parents enhance the height of their children? And again, some athletes have prosthetic devices to overcome disability that actually enable them to run faster than athletes in the, if you like, non-adjusted population. And then, just a few weeks ago, here in Sydney, as you might have read in the press, a research group announced that they were planning on using kangaroo tendons for the treatment of ruptured human ligaments. Well, it turns out the kangaroo tendons apparently are 6 times stronger than the human equivalent. So will the humans who receive them be enhanced? I guess so, and I want to know, will they be able to leap around like a kangaroo? But I guess we have to wait to find that out. In any case, in July this year, the respected Nuffield Council on Bioethics produced a report entitled Genome Editing and Human Reproduction. Somewhat to people's surprise, including my own, in fact, they rather blurred the distinction in this report between healing and enhancement. But I think just because there's a fuzzy boundary between healing and enhancement, we don't need to drop the distinction altogether. One may argue whether the speed limit should be 50 kilometers an hour in urban areas, or maybe it should be 48 kilometers an hour, or maybe 52, but everyone has agreed that 110 kilometers an hour is inappropriate for an urban area here in Sydney, and that on the open highway, a limit of 10 kilometers an hour is not much good either. Okay, so in other words, binary distinctions, I think, still remain helpful, even if they are demarcated by a fuzzy boundary, and that's the position I'm going to take this evening. Now, what ethical tools do we have at our disposal to address the increasingly pressing questions arising not only from the genetic engineering of humans, but also from the many machine-based enhancements, including cyborgian enhancements that we were considering in Lecture 1? What I want to do now, very briefly, is to summarize the 4 main ethical tools in current use. I'm sure you're very familiar with these anyway, sort of Ethics 101 coming up here. But I want to just briefly summarize, so we're on the same page on this, and then see how our three main rival worldviews modify and expand those tools in ways that make big differences in how we address the question of human enhancement. We start with natural law ethics, first laid out for us systematically by Thomas Aquinas in the 13th century, great theologian, philosopher, influenced, of course, by Aristotle. And in this system, good and evil are derived from the God-endowed rational nature of human beings and are both objective and universal. We respond to ethical questions by asking the question, is it natural? We expect to find certain universal moral principles because these are inherent within humanity and the nature of things, according to natural law ethicists. Second, utilitarianism, famously associated with the philosopher Jeremy Bentham, very influential philosopher in the early part of the 19th century, and the idea here is that ethical decisions should be judged by their practical utility. Who will benefit? Do the procedures involve pleasure or pain? Are the costs worth it? The philosophy is therefore closely connected to consequentialism. Well, will the outcomes entail good or bad consequences? Thirdly, deontological ethics, term derived from the Greek deon, obligation or duty. This means obeying universally valid rules, whatever the consequences might be. Sometimes called rule-based ethics because the main aim is to adhere to a particular set of rules. And for example, as been pointed out by people maintaining this perspective, there is something inherently paradoxical in using language to communicate an untruth. That's what a deontologist would say. Fourth, virtue ethics. The key question here is, of course, what kind of person should I be? What actions will encourage virtuous qualities in myself and in others? And along with this ethical toolkit, we also note three main stances taken towards the status of the early embryo, because clearly these will impact on attitudes towards the prospect of embryo editing. I'm going to call the first position the absolutist position, because in this deontological view, the newly fertilized egg receives from God a soul. It is ensouled in such a way that it gains the full value and rights of an adult human. So IVF and all forms of embryo manipulation are simply wrong in this view because they entail the death of early embryos. The second main position I'm going to call the gradualist position. This suggests that human personhood is an emerging phenomenon that gradually develops along with embryo development. Therefore, the embryo deserves our protection from fertilization onwards, but it's not an absolute protection. And consequentialist arguments may then be used to justify discarding unwanted early embryos for the future good of the wanted or healed embryos. And this position is also often linked to a different view of the soul than the first position, in which, in this case, the person is seen more, perhaps in the Bible, as a sort of body-soul-spirit unity. And so that's different from a more, if you like, Neoplatonic view, in which the soul is seen as a separate entity, which is breathed by God into the new human person at conception or at some early stage during fetal development. And as we all know, there are certain milestones in fetal development, such as implantation, about 4 to 6 days after conception, when the mother becomes pregnant, or the so-called primitive streak at around 14 days, the first beginnings of our nervous system, or the quickening of the growing fetus when baby first starts kicking. And these milestones are all vital in their own way in early human development, and the 14-day point is enshrined into law in many countries as the point beyond which human embryo development cannot be allowed to proceed in vitro, at least for the time being. Others point out that in natural pregnancies, only around 20 to 30% of fertilized eggs make it all the way through to the birth of a child. And the great majority of loss occurs through failure of implantation, often due to major chromosomal defects in the blastocyst, this little ball of cells that emerges from the fallopian tubules into the uterus a few days after fertilization. So there is a kind of natural selection going on all the time, whereby unfit blastocysts are being weeded out. They would never proceed to term because they suffer from very major chromosomal abnormalities in a certain percentage of cases. And of course, many women will not be aware at all that this happens as the plastocyst is tiny, smaller than a pinhead. The third position we can call the embryo has no special value position. And in this view, that little tiny pinhead blastocyst has no particular value because it's just a tiny bunch of cells, and the embryo may be discarded at virtually any safe point up to birth if it is defective in some way. In fact, as we were considering last night, if you're a radical utilitarian, like the philosopher Peter Singer, for example, then if even after birth it turns out that the baby is handicapped in some way, then according to his radical utilitarian philosophy, it's also justified to commit infanticide, to kill the newborn. So there we have a sort of threefold taxonomy for the purposes of discussion this evening. We have the absolutist, we have the gradualist, and we have this embryo has no value position. So how do our three rival worldviews treat the use of the four ethical principles, and what are their attitudes towards the three main ethical positions concerning human embryos? Let's think first of all about transhumanism. Well, here utilitarianism is clearly the key principle at stake, and as we were considering in lecture 1, often transhumanists tend to have a very low view of biological life, pointing out all our many defects, and they don't assign to the embryo any particular value. In their view, generally speaking, if embryo editing eliminates disease-causing genes from a particular family lineage in a safe way, or equally if we make people more intelligent or stronger or less aggressive, then of course we should do it. From the perspective of many transhumanists, our failing biology is just one stepping stone along the way to achieve super-intelligent people who will then make super-intelligent machines, leading ultimately to digital immortality as a result of the great singularity yet to come, in which the super-intelligent machines become autonomous and self-aware. This will now take place in the year 2045, according to the latest estimate from Ray Kurzweil. So I'm just afraid us older folk here this evening are going to miss out. Sorry about that. From a biological perspective, there does seem a considerable amount of naivety, I think, in the transhumanist literature concerning the potential of genetic engineering to generate humans with greatly advanced intelligence. Those at the lecture last night will remember that whereas around 50% of the differences in biometrically measured forms of intelligence, such as IQ, can be attributed to genetic variation, there are hundreds or perhaps thousands of genetic variants that contribute to the heritability, each one contributing 0.1% or less to the overall variance in the population. So the human genome is a very complex system. I put this one up. This is not what I showed you last night. It's just a very recent paper that came out a couple of weeks ago, published in Nature Genetics. And this was a study carried out on a huge cohort, 1.1 million people of European descent, revealed 1,271 genetic variants associated with a degree of higher education in that particular population. But all those 1,271 variant genes only explained 11% of the variability in the population with regard to higher education. Okay. So imagine, we're talking here about thousands and thousands of genes. So as I say, the human genome is really a very complex system, and improving complex systems is very complex. And you would potentially, as I say, need to change thousands of genetic variants in order to generate a single individual with much higher intelligence, or let's say intelligence at the top of the scale of the normal human population. In any case, if you're going to use a utilitarian argument, why would you want to do that anyway? What's the point? Okay? Out of great intelligence can come great evil. How would it be fair at school if the genetically engineered enhanced pupils did so much better than the normals? All that would happen is greater social inequality. And if you went for athletic prowess as your enhancement ideal, don't we call that doping in the world of sport? Is that really the best we can do for the future of humanity, create more disparity between people? Don't we have enough disparity already? I think there's also a striking unawareness in the transhumanist literature concerning the pleiotropic effects of possible gene modification. This refers to the fact that changes in one gene may have multiple and unpredictable changes in the actions of other genes. Now, that might not occur in the particular individual who is being genetically modified, but it might occur in their descendants, where the modified gene encounters new genomic environments. This is well illustrated by a famous experiment in which the Russian geneticist Dmitry Belyaev successfully bred foxes to make them tamer, but over the generations they displayed all kinds of other unwanted traits such as increased stress responses, changes in skull shape, sexual immaturity, that kind of thing. And so it's also clear at the same time that some genes protect us against disease. A single copy of the gene that causes the blood disease thalassemia that we mentioned just a moment ago protects against malaria. A double dose of the gene and you get thalassemia. A single dose and you get protection against thalassemia. So if you change the genes of someone in their germline, the sex cells, to pass on the information to the next generation, how can you be sure that their descendants will not lose some vital protection against disease? And even with genetic healing, let alone enhancement, there is issues here of social justice. A science fiction writer, William Gibson, once commented, and I quote, "The future is already here, it's just not very evenly distributed." If embryo editing becomes widely used for the healing of embryos, two consequentialist issues immediately arise. The first is the fact that, at least in the first instance, the technology will only be available to a tiny minority of people living in rich countries, although, of course, you could say the same about any high-tech new medical therapy. The second issue is more specifically relevant to gene therapy. Assuming that the genetic defect being cured is non-lethal, allowing development to adulthood, then what does this say about the value of the community who may already be united in experiencing this difference from others? Well, in April this year, a research group from Harvard and MIT reported the use of CRISPR-Cas to cure deafness in so-called Beethoven mice that carry a gene defect found in both mice and in humans that you need for hearing. So the procedure involved replacing the missing good gene in individual mice, not in a way that the mice were cured in their germline in the first instance. And clinical trials are expected soon in people, perhaps supplementing the use of cochlear implants. So embryo editing of the defective gene is a distinct possibility for the future, thereby enabling an individual carrying this mutation and all their descendants to hear rather than being deaf. Now, clearly, deafness is not normal in the sense that hearing is generally a property of most people in the world, but many in the deaf community reject the notion that deaf people need to be cured or otherwise treated to eliminate or circumvent their lack of hearing. Some deaf people see their deaf community as a cultural community, rather like an ethnic minority, which is all just to say that even healing and issues around healing can be complicated, let alone the radical aspirations for enhancement being made by the transhumanists. Well, what about middle-of-the-road Western secular humanism? How does our ethical toolkit fare within this particular metaphysical worldview? Well, we've got here, I think, a very broad collection of views in reality, but perhaps a few generalizations are possible. As with transhumanism, consequentialist arguments play a prominent role. One of the striking aspects of the Nuffield Report already mentioned is the consequentialist tone of its conclusions. As the foreword to the report points out, any kind of genetic modification to an embryo is acceptable, providing two criteria are satisfied. First, the welfare of the individual to be born must be paramount, and second, such interventions would uphold principles of social justice and solidarity. By this, we mean that such interventions should not produce or exacerbate social divisions or marginalize or disadvantage groups in society. Close quote. Now, such consequentialist arguments, they're fine as far as they go, but I think it's more the absence of other tools within the ethical toolkit that I find most striking in this particular report. Pragmatic sociological arguments are prominent, as the foreword also highlights in answering the question, why bother with embryo editing, the answer that it gives, and I quote, is that the answer offered in this report centers on the reproductive choices of prospective parents and the preferences they may express for their future child. Close quote. So the bioethics of the Nuffield Report really comes down to a regulatory question. How should we regulate this new technology in such a way that people's wishes are satisfied without harm to the genetically modified child and without harm to the others, to anybody else? Well, the question of the value and status of the early embryo is simply ironed out of the narrative as far as I can see. And I think MOR-WSHers generally place themselves in either the milestones in development or embryo has no special value categories when it comes to the status of the early embryo that is to be genetically edited. Now, deontological positions are by no means lacking amongst MOR-WSHers, but they tend to focus more, I think, on government laws, policies, regulatory issues. There is currently, of course, a moratorium, as I was mentioning, on using genetically modified embryos for reproductive purposes in most countries of the world, where this sort of technology is being developed, including, of course, Australia. Australia has one of the strictest regulatory environments for gene editing research in the world. Now, from a consequentialist perspective, the scientific community are also, in this context, very concerned that some researcher will jump the gun before CRISPR is perfected and reproductively generate children from genetically edited embryos, perhaps leading to some terrible consequences arising from safety issues, such as cancer due to off-target mutations, that sort of thing. And the worry here, the pragmatic worry, is that this could lead to a loss of funding for research, it could delay the human applications of the research by years, and so forth. These are the kinds of pragmatic concerns expressed by co-inventor of CRISPR-Cas, Jennifer Doudna, in her book, A Cracking Creation and the Unthinkable Power to Control Evolution. So here, pragmatism rules. Now, as far as natural law, ethics, and virtue ethics are concerned, very difficult to generalize amongst MOR-WSHers. It's a very broad denomination, as I was mentioning. The range of opinions here are very great indeed. But I do think it's fair to say that utilitarian arguments hold sway overall, and virtue ethics, as far as I've noticed, receives relatively little attention. Sociologically, one end of the MOR-WSH spectrum merges with transhumanism, whereas the other end finds common cause with Christians, sometimes campaigning together for the same pragmatic outcome, albeit without the specifically Christian motivation. Which brings us to our third main competing worldview, that provided by Christian theism. What I'd like to do here is not only outline the key entailments of the Christian worldview, but also to take this opportunity to show how these entailments address some of the concerns raised by both the transhumanists and the MOR-WSH positions, both in the area of genetic engineering as well as the envisaged role of AI, superintelligence, and cyborgs. So in the first lecture, we highlighted three strands in the idea of humankind made in the image of God that I think are highly relevant to the question of what it means to be human. First, humankind, male and female, as the embodied self, with its entailment of the value, the high value, of human physicality. Secondly, being made in the image of God guarantees the value and status of each human individual, irrespective of their physical status. And the third entailment is personal human responsibility and accountability to God and to each other, how our particular genomic endowment guarantees the development of persons with real free will and responsibility, lecture last night, excepting only cases of severe pathology. And last night also we added a fourth entailment, namely our sheer diversity that makes human relationships with each other and with God central to the idea of humankind made in the image of God. So how does all that work out in the complex world of human healing and enhancement? I think what Christian theism does is not to give a list of rules so much, but rather a framework of goals, principles, constraints that make a huge difference when using our ethical toolkit and when considering the status of the human embryo. So I want us to spend a few minutes now just tracking those entailments and see how they impact on our ethical discussion. The fact that God loves each human individual, irrespective of their class, color, background, genetic endowment, educational ability, whatever it is, I think makes an enormous difference to this discussion. Each human being within this framework has an absolute value because made in the image of God, however much that image may have been marred by sin and selfishness. So healing is at the heart of Christian faith. Jesus, of course, giving us the supreme example. As the crowd surrounded him, Luke 9:11, Jesus welcomed them and spoke to them about the kingdom of God and healed those who needed healing. Matthew 14:14, when Jesus landed and saw a large crowd, he had compassion on them and healed their sick. And often in the Gospels, the healing miracles of Jesus are linked to the coming of the kingdom, God's reign over all things. In the future fulfilled kingdom, all those who have identified with the risen Christ will be recreated perfectly in the image of God in their resurrection bodies. Resurrection bodies. So healing people now is a sign of the coming of the kingdom. As we follow Christ, those of us who do in the ministry of healing in the present age, so we are pointing, we believe, towards that time where God's rule over our physical bodies is finally complete. It will never be complete in the present age in which we're living, but it certainly will be in the age to come, the future fulfilled kingdom of God. So why didn't Jesus heal everyone? Well, he did heal all those at the time in his immediate context who came to him by faith. But in a sense, what Jesus was doing was to give us a taste of the future kingdom. It's like the door to heaven opening in a sense of the power and possibility of the future kingdom breaking into the present age. Think of the smell of freshly baked bread when it wafts around your house. Something like that. Something of the future coming into the present. Something which is really wonderful to think about, which is now impacting to some degree on our present lives. But now, in the Christian vision, the healing task is given to the followers of Jesus, indeed, of course, to the whole of humankind. Founding of clinics, hospitals, was a feature of Christian faith from its earliest years, and still to the present day, particularly in the poorest parts of the world, its healthcare is provided with Christian initiative and support. Well, what we can achieve now in terms of healing on planet Earth is always, as I say, going to be partial. It's a bit like a pilot plant, if you like, which provides a working model as to what the future reality is going to look like. And our task now is to make that healing plant as efficient and as complete as we can, particularly keeping in mind the needs of those less fortunate than ourselves. But I think Christians on the whole would maintain that healing is generally very different from enhancement. Think of the restoration of Michelangelo's famous paintings dating from 1508 to 1512 on the ceiling of the Sistine chapel in Rome. They were actually last restored over the period 1980 to 1994, but the task of the restorers was not to try and improve on the artist's creative intentions, but to restore the beauty of the paintings to be as close to the original as possible. So Christians believe that we have a mandate to heal from Jesus himself, but that techno-scientific aspirations for enhancement are quite likely to spoil the intentions of the Creator. But then, what about the healing of human embryos by embryo editing? Would Jesus heal early embryos? What about those many hundreds of cases, thousands of cases, in which there's a single point mutation, single change in a single genetic letter in the genome that will definitely lead to a lethal genetic disease in early life? Many of the diseases I worked on in the Middle East would kill kids before the age of 10, for example, slowly and painfully. Should we prevent that? As I say, would Jesus go around healing early embryos? Well, I don't think Christians are going to speak with a single voice on this issue because their views on the early embryo are not going to be precisely the same. I think all view the early embryo as precious because created by God and worthy of our protection to the very best of our ability. Some Christians will take the absolutist positions that the early embryo is ensouled by God and therefore deserves the full rights and protection of an adult human, whereas I think others might adopt the more gradualist position that the embryo deserves increasing levels of protection as development proceeds towards an independent human existence. And those adopting, of course, the absolutist position will be unlikely to be happy with IVF, as I said earlier, because of embryo wastage, whereas the gradualist is perhaps more likely to accept IVF. And in turn, the gradualists may also point out that there really is no point, as I mentioned earlier, in embryo editing, because pre-implantation genetic diagnosis is available in the great majority of cases, or will become available soon, and overall involves far less risks and ethical dilemmas than genetically modifying the human germ line. But if you're a gradualist, then in principle one could argue that the healing of embryos from lethal diseases was a Christian duty. It's just that in practice there seems little point when PGD is available, given that both techniques involve IVF anyway. And then, in addition, there's also the slippery slope argument hovering in the background that if and when embryo editing is perfected, then the pressure will be on to use the same technology in ill-conceived enhancement experiments. Human life for the Christian is a gift, it's not an achievement. And enhancement makes no sense unless it has reference to what the Creator intends for his gift. And I think this is why virtue ethics plays a very large role in Christian thinking on this point. But what virtues? In transhumanism, I think it's fair to say it's financial investment that sets the goals, because without investment, technoscience won't flourish. And so the virtues are efficiency in the workplace, productivity, submission to authority, and assertiveness, the sort of qualities that drive the worldwide economic engine. Christian virtues center more on kindness, humility, love, generosity, the kind of virtues that flourish in community and that help relationships to flourish. And this flourishing takes place in human communities that are diverse and with limitations and weaknesses that entail that its members have to rely on one another. And that's in striking contrast to the transhumanist vision, in which the reliance is to be on machines or genetic modification to achieve the perfect future for the individual, with not much interest, as far as I can see, in the relational community. The quick fix to the better human is prominent in the transhumanist literature. Here's the transhumanist and philosopher Mark Walker, who has theological interests, and whose name I was struggling to remember, I think, on the lecture one, and I forgot during the question time. Anyway, his name is Mark Walker. He thinks we can improve morality and virtues via genetic engineering. In an article that came out just last month, Professor Walker writes, and I quote, that the implications of the genetic virtue program are clear. If we can locate the genes associated with agreeableness and increase their frequency, then we may increase the virtue of caring in a population and reduce the vice of uncaring. Close quote. Sounds pretty good, doesn't it? But I would want to comment, there seems to be a yawning gap here between transhumanist aspiration and scientific reality, as I was hinting just a moment ago. Hundreds of genetic variants contribute to the variation in a population of a complex trait like agreeableness. And in any case, would you really want to engineer super agreeable people? Those who don't stand up to injustice, who are super passive in the face of adversity? I don't think it would do American sports much good if we did that. And, where would the cricket go? All kinds of questions there. But I think the problem with many suggested genetic enhancements, for example, to reduce aggression in the human population, is that the likely outcome would be passives. I would say super boring people. Do we really want that? Now, the point about Christian virtues is that they develop through the actions of God the Holy Spirit, working in people's lives via their own free will to produce the fruits of the Spirit. And establishing good habits is what leads to good virtues. So I suggest it is a category mistake to look for the genetic causes of virtues, because the whole point of a virtue is that it develops as a process that involves human effort and free will, and for the Christian is coupled to the work of the Spirit in bringing about a transformation of life. It is persons who are virtuous, and there are no shortcuts to virtue. which brings us to the entailment of personal moral responsibility, a key aspect, as we've been emphasizing, of being made in the image of God. So, in the transhumanist future, humans will increasingly have their criminal or antisocial tendencies abated by use of machines or by genetic engineering. The transhumanist Oxford philosopher Julian Savulescu has even proposed that the moral modification of criminals or those with criminal tendencies should be compulsory, with moral modification referring to genetic or cyborgian techniques. As a matter of fact, I think in that context, the cyborg might be a more realistic option. In Lecture 1, I conjured up an imaginary scenario, which still belongs to science fiction, thankfully, in which paedophiles have implants in their brains linked to a police computer that sends signals to inhibit their paedophilic impulses once detected. Is that the kind of human future that we want? One can readily see the way that such a technology could develop. If you can use implants to inhibit paedophilic thoughts or stopping actions before they're initiated, then why not use them for aggression more generally, or for inhibiting murderous thoughts, or maybe for inhibiting anti-government thoughts? But being made in the image of God entails that we do all we can to maintain personal human responsibility, for only in this way can we preserve justice, culpability, authentic human relationships, love, ultimately our responsibility to God. As I say, the blunted person is not virtuous, but just dull. The final entailment of being made in the image of God that I'd like to highlight this evening is the precious physicality of humankind, humans as the embodied self. The New Testament envisaged the human future as being located in the resurrection of the body, not the immortality of a Platonic soul. When Jesus rose from the dead, the tomb was empty, and the grave clothes were left lying intact. He rose not as an ethereal spirit or ghost, but as a resurrected person, a different form, a transformed physicality, with the wounds of the crucifixion still visible in his body. But for the MOR-WSH person, death, of course, is the end of the story, and so that's that. For the transhumanist, the immortal human future lies in a disembodied digital existence, with our failing biology left well behind, with its explicit denigration of human physicality. As transhumanist Simon Young writes in his book Designer Evolution, a transhumanist manifesto, and I quote, "The belief in the fall of man will be replaced by the belief in his inevitable transcendence through superbiology," close quote. But when you look to see what superbiology means in transhumanism, it always seems to end up in pure digital mind without a body inside. In fact, I have to say the transhumanist digital future also sounds really boring. No body, no friendships, digital space where computer geeks might be happy, but nobody else. And in any case, an eternal future for fallen humanity would just give corruption an everlasting license, to use the potent phrase of theologian Ted Peters. So what you believe about the future, what Christians call eschatology, really does make a difference to the present. For in the Christian vision, it is not only humanity who are to be redeemed, but also the whole created order. As Ted Peters put it this way very nicely, I think, God calls each of us individually and the human race as a whole towards a divinely appointed end or goal, namely our true humanity in participation with a redeemed and healed creation, close quote. This entails not the cartoon image of angels playing harps and clouds, but a new heavens and a new earth with resurrected persons enjoying completely fulfilled lives with God and each other, not as a result of their techno-scientific striving, but as a result of God's grace. So, what can we conclude then about technoscience and the future of humanity? We started this lecture series by thinking about Bacon, Francis Bacon, and his Christian vision to use the new science for the good of humanity. Bacon's vision has surely been fulfilled beyond anyone's wildest dreams. And as a Christian, I rejoice in that. I spent my whole life in research in science and in its applications in technology. I rejoice that genetic engineering and machines are beginning to have success in curing genetic diseases, in curing cancer, in enabling the blind to see, the deaf to hear, and the lame to walk. And that list will sound familiar to Christians who will think of John the Baptist, who was sitting in prison after upsetting King Herod and wondering whether Jesus really was the Messiah as he had been previously proclaiming. And so John sends his disciples to check out the situation, and Jesus told them, "Go back and report to John what you hear and see. The blind receive sight, the lame walk, those who have leprosy are cured, the deaf hear, the dead are raised, and the good news is preached to the poor." Well, that's the Christian vision for the human future. But due to our own human failing and sin, Christians are also only too aware how quickly we can place false hope in our own creations, be they new machines, new techniques for genetic engineering, or something else. I think we, humanity, have a long history of putting our faith in gods that fail. I hope that what we've seen during these 3 lectures is that the worldview we adopt makes a huge difference to our vision for the future of humanity. When it comes to our ethical toolkit, then the worldview amplifies one tool in the ethical toolkit at the expense of another. Transhumanism amplifies utilitarianism, as does MOR-WSH as well, to a large degree, whereas Christian theism amplifies virtue ethics. I think it's fairly clear historically that we see that Western humanism, what we've dubbed here MOR-WSH this evening, derives its value system from many centuries of Christian influence, and is now seeking to live on the fruits of that investment without the underlying and sustaining worldview. How long the fruits can be maintained without the roots is a moot point. In turn, transhumanists were mostly previously MOR-WSHers, but have shifted to a more structured ideology which attempts to mimic major Christian themes, albeit by a set of secular aspirations, which often lack, I would suggest, scientific realism. So, my suggestion in these lectures is this: why don't we rebuild the theistic matrix within which science not only flourishes, but also humanity flourishes through fruitful relationships with each other, and also fruitful relationships with God, who is the one who ultimately will decide our futures. Thank you for your attention.